How am I going to solve this? I've got a cos in it and a sine in it.
Do you do the last one? Divide just the first one.
I'm going to use the first one to replace either the cos squared or the sine squared with something involving the other.
Use simultaneous equation.
Essentially, yes.
Oh, okay.
There is another way. I mean, if this is tech active, you can get your calculator out and graph cos squared and graph, or cos squared minus a half and graph sine squared and find where they meet.
Wouldn't it be faster to do simultaneous?
If I want an exact answer, I don't want to do it that way.
Okay.
Right? So, yes, we're going to pick one of these and replace it using this, because this tells me that cos squared theta is 1 minus sine squared theta, or sine squared theta is 1 minus cos squared theta. Remember that question from the last exercise, right, near the end, Ben? Were you doing this one as well?
Probably, yeah.
I said this is leading straight into what's next. Do you want to replace cos squared or do you want to replace sine squared?
Cos squared.
Okay, it's different from the book, but it should still work. So instead of cos squared, we're going to write 1 minus sine squared. 1 minus sine squared x minus sine squared x is a half. 1 minus 2 sine squared x is a half. Negative 2 sine squared x is negative a half. Sine squared x is a quarter. Not finished yet. It says solve, I have to find a value for x. Well, I can tell you what sine x is. Plus or minus a half. Do you need a calculator for that? You need to be able to do it, take 3. Normally we would only have a positive or a negative, so we don't have 2 solutions. Here we've got plus or minus, so we need 4 solutions in this domain. X is going to be, so it's 30 degrees pi on 6, here, 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 or here. Pi on 6, 5 pi on 6, 7 pi on 6, 11 pi on 6. 4 solutions. Did I go too quick there at the end? All got that? Do you want another one like that, or is that clear enough?
It's clear.
Clear? All okay? Okay, Ben? Okay. And let me give you a different kind of one. Let's try simplify. Let me use my camera. Cos squared plus sine squared plus 1 over cot squared. Well, straight away, what's cos squared plus sine squared? 1. 1 over cot is going to be tan again, right? Because cot is 1 over tan.
Did you just reciprocal or reciprocal?
And what's 1 plus tan squared?
It's sec squared.
Well done.
Oh, yeah.
Harder one?
Yeah.
Okay. I'm going to need my hook to get this right. sine theta over 1 minus cos theta plus sine theta over 1 plus cos theta, where cos theta is not plus or minus 1. Why is that important?
Because you can't divide by 0.
Because I can't divide by 0, correct.
Can you please?
Give you a moment to write that. The year 10s are currently whinging about having to do algebraic fractions. Now I have algebraic fractions with trig.
The tens are dramatic.
What do I have to do to simplify this? I've got to add some fractions together. Lowest common denominator. Multiply these two denominators together. I want it over 1 minus cos theta, 1 plus cos theta, which is a pattern you should recognise. Brain definitely recognises that.
Yeah.
What goes on top? Sine theta times 1 plus cos theta plus sine theta times 1 minus cos theta. Doesn't look simple yet.
It does a little bit.
It's going to. What's on the bottom of that fraction?
There's things on the top.
What's this? Minus plus.
What do you mean?
We can explain.
There must be a
Difference of squares.
squared.
So on the bottom is 1 minus cos squared theta. Hint, we're going to replace that next.
Ooh.
What's on the top? Sine theta plus sine theta cos theta plus sine theta minus sine theta cos theta. That's a bit of a mess.
Can we like backtrack for a second?
Sorry? Yeah, lots of stuff's going to cancel.
Sine theta plus
1 plus cosine theta, is that sine?
This
Oh, you
Times
just
this.
expanded. Yeah, yeah, yeah.
and then this times that.
Yeah. That was stupid.
Expanding brackets. Do you want me to draw the bridges in? Will that help?
No, it's
Okay. I can go back to grade 8 if you like,
It's okay.
if that's what we need to do.
Is it cosec theta?
Well, what's on the bottom is sine squared theta, right? That was one of our identities.
Yeah.
1 minus cos squared is sine squared theta. Up here I've got plus, minus, those terms go away.
2 sine theta.
2 sine theta, so you're close to the correct answer.
Cosec.
2 cosec theta.
2 cosec theta.
The 2 stays there. This sign cancels the square, cancels one of the signs. I'm left with 1 sign on the bottom.
Oh, where'd my 2 go?
I don't know, where did it go? So you see how we're putting together things you learnt in, well, grade 8, grade 7, along with things you learnt in grade 10, along with a little bit of new stuff, just literally 3 identities, and now you can simplify this kind of stuff. Oh, no, sorry.
It's okay.
Why can't cos theta be -1?
Where?
You said cos theta can't be plus or minus 1.
Because if it's -1, this one's 0.
They're both negative.
Question. If
Yes?
they cancel out and then if you're only left with sine theta on the bottom, is
Sine
it?
squared theta. 1 minus cos squared is sine squared theta.
Yeah, but then if the top, like the next step, doesn't the sine cancel out and then it's only left with 1 sine?
Yeah.
Sine theta and sine squared theta. So this one cancels one of the sine
And you
thetas.
have 2 over sine.
So it's 2 over sine theta.
To get to cosec doesn't have to be 1 over, or in this case 2 over sine squared
It's
theta.
2 times 1 over
No, just the definition of cosec.
Sorry.
This is 2 over sine theta. You agree with that, right?
Yeah.
Well, isn't that 2 times 1 over sine theta?
Yeah.
Which by definition is 2 times cosec theta?
Is cosec Does it not matter if it's squared? Oh, sorry, I'm being stupid.
Yes,
Yeah,
correct.
I get it.
This is just a simple
Yeah.
reciprocal tree.
Okay.
That's all. And a hard one. Eeny, meeny, miny, mo. Let's do that one. Prove cos x over 1 minus sine x equals sec x plus tan x. And at first you look at that and go, what? How do I do that?
Times both sides of 1 minus sine x.
It's times by something very similar to it.
Or do we want to get rid of the denominator?
How did we change this denominator into something with a squared in it?
Multiply it by...
We change the sign when we multiply.
Yeah.
Ryan, this is like a conjugate. Okay? So we're going to take the left-hand side and we're going to go cos x over 1 minus sine x, and we're going to multiply top and bottom by 1 plus sine x. Top and bottom. Because then we're not changing it. Do this process, expand it, see how you go.
What do I do wrong here, sir?
First of all, this is a function. It needs an argument every single time. Like this, every time. Now, what did you do? Well, from this...
Yeah, let's put that into one of his cosine.
Oh, you're doing the right-hand side first, yes. We will be doing that.
No, that. So that equals that. How's that equal that?
Well, that's what you have to prove. Never write it like this. Always go left-hand side and then right-hand side. For this one, that's why I chose this one, you're going to have to manipulate the left and the right and simplify both sides and show they're the same.
Oh, okay.
Okay? So yes, you do need to do that to the right. You got... Oh, you haven't got there yet. You're going to. This is going to give me cos x 1 plus sine x plus... No. What am I doing? That's not what I'm doing. Oh yeah, it was right. Cos x 1 plus sine x over 1 minus sine squared x. Did you get that?
Got the bottom, not the top.
Did you multiply across the top? That times that. What's next? Expand the brackets and replace 1 minus sine squared. Now I have a sum on the top. I can work with a sum on the top in the way I can't on the bottom. So this is cos over cos squared. I better write one extra line so you can see it. I wouldn't actually bother writing this in my final proof, but I'm doing it for you. Cos x so you can see what I'm doing. This one is 1 over cos x. And this one is sine over cos. That's about as simple as I can make them. Let's try the right-hand side. Oh, wait a second. That is the right-hand side. I can stop. Yep, I can stop. So you can go backwards if you're careful, Ben, because you start with this, replace, divide by... You can get there. only trick here that we did that's different and new, I don't like a sum on the bottom, I'd rather have it on the top. Multiply top and bottom by something called a conjugate. You'll see many cases of this. Change this sign so that when you expand it, you get a square. Same trick as what this did.
So
Difference of squares.
like the aim is to get squared on the bottom, so you can see.
Why? Because that can be substituted. Yep.
So rationalise the denominator.
Essentially, yes. It's the same process as rationalising the denominator. It's the same process when you get to complex numbers. That yes, you'll see this kind of idea many times. That's why I know Ray's seen it before many times. We have done that before.